Okay, so again, we're looking at the third set of notes here from Chapter 1. These notes cover sections 1.6 and 1.7. You'll notice we're going to start these notes with just a few definitions, okay? And these are going to be some things that we're going to discuss throughout the entire course, really. So you're going to want to really focus up here, not that you shouldn't always, but specifically on these first few ideas. So a function, okay? A function is... Okay, first of all, there's domain and ranges. Okay, so when we talk about a function, we think domain and range. Domain is the set of inputs, and the range is the set of outputs. Now, one thing I want to be sure that we're clear on, oftentimes we refer to the domain as the x, okay, as the x's, and the range is the y's, but do understand that those variables will change based on the situation, okay? And so what a function is, it's a pairing of inputs with outputs. So let me write this down. It's a pairing of inputs and outputs in which each input is paired with exactly one output. Okay, where I've got to go down below here now. Where each input is paired with, and this is important, exactly one output. Okay, I apologize, I ran out of room there. Hopefully you'll be able to write small enough to get all that on one line. So again, a function is very simply a pairing of inputs and outputs where each input is paired up with exactly one output. All right. Okay, I'm going to have to erase this, so if you need to, continue copying this down, just go ahead and pause the video and take care of that. All right, as we move forward here now in the with these notes, we're looking at independent and dependent variables. Okay, independent versus dependent variables. So the input variable is the independent variable. In other words, when we're talking about the independent, that's where you have the ability to put in whatever you want. Okay, so these are the inputs, and the dependent are the output. In other words, whatever you put into the function will create an output. So the output depends on what the input was. Okay, and so that's where these names come from. Okay, it says the input-output table shows temperatures over various increments of time. Identify domain and range. Okay, so in this particular example, pretty straightforward. The domain is the set of all inputs. Okay, so your inputs are 0, 2, 4, and 6, and your range is the set of all outputs, which in this case are just 24, 27, 30, and 33. You would not say 24 to 33 because 25 is not an output of the function. All right, so just 24, 27, 30, and 33. All right. So that should be pretty straightforward, guys. When you're talking domain and range, look at your inputs, look at your outputs, and then those are your domain and range. All right. The second example here, I'm going to scroll back over just a little bit, says the domain of the function y equals x plus 4 is 0, 2, 3, 6, and 7. Make a table. Okay, so first thing I'm going to want to do is I have my input values, I have my output values. My first input is 0. My second one is 2. I can go ahead and fill all these in right away because I know that these are what I'm putting in. These are independent, so they've determined for me which ones to plug in. Now I just got to plug them in. Okay, so when I plug 0 in for x, okay, when I plug 0 in for x, I get 0 plus 4. So that tells me that y is 4. When I plug 2 in for x, again, I'm looking at this guy here. When I plug 2 in for x, 2 plus 4 tells me y is 6. 3 plus 4 is 7, 6 plus 4 is 10, 7 plus 4 is 11. And then part B here says identify the range. Well, again, the range is just this set of numbers. Okay, so your range would be 4, 6, 7, 10, and 11. Okay, and that would be what your range is for this particular function. All right. Now we're going to transition into taking a look at graphing a function. You're going to notice we're going to do a lot of work going from tables to graphs, from graphs to equations, from equations to tables, etc., etc. Okay. So just a few things here. First of all, we can use a graph to represent a function. Okay. We can use a graph to represent. Make sure I get this right. There we go. To represent a function. I don't think that's any secret. You did that last year a lot. Okay. In a given table, each corresponding pair of input and output values forms. It should be A. Okay. And I'm gonna just kind of write it down here because I don't feel like scrolling over. Coordinate. Okay. It forms a coordinate, or I guess you could call it an ordered pair. Okay, that's actually what I should have put there. All right, so coordinate, ordered pair, same thing. You have an x and a y. All right, an ordered pair of numbers can be plotted as a point. All right, the x coordinate is the input. The y coordinate is the output. Okay, so again, that's just what we're talking about there as we're graphing. Again, this should be review. I'm assuming that when we go through this next example, you're going to sit there and say, "Oh yeah, I remember this now. This is pretty easy. This is review stuff." Okay, so it says graph the function y equals x plus 1. Domain is 1, 2, 3, 4, and 5. So immediately I know what my input values are: 1, 2, 3, 4, and 5. Now I just plug them in. Okay, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6. And then we just got to go ahead and graph this thing. Okay, so I plot the point 1, 2. Remember, x's are left and right, y's are up and down. So the point 1, 2, that's the first one. And then the point 2, 3. And then the point 3, 4. And then 4, 5. And then 5, 6. Okay, I'm not going to connect them because, again, my domain is strictly those numbers. If my domain was everything in between them, then I would connect the dots. But I don't want any values other than 1, 2, 3, 4, 5, and 6, 1, 2, 3, 4, and 5 for my domain. All right, so again, should be review material. All right, so again, just kind of plugging away here. On the back side of your notes, you'll see we're looking at example number 4. All right, it says write a rule for the function represented by the graph. Identify the domain and range by the chart. Okay, so really, I shouldn't have said it's for part A. We're going to write a rule here as well. Okay, so when you look at what you're looking for is a relationship between each input and output. Okay, so how do I go from 1 to 0? How do I go from 2 to 1, 4 to 3, 7 to 6, 9 to 8? And if you look close enough, you'll notice. Okay, very simply, subtract 1, subtract 1, subtract 1, subtract 1, subtract 1. All right, so your rule here, okay, your rule, I'll scroll down just a little bit. I don't want to take this off the page though. Okay, so our rule for this particular problem is going to be just take your inputs, there we go, and subtract 1. Okay, so your rule is going to be your output equals your input minus 1. Domain is all your inputs, 1, 2, 4, 7, 9. Your range is all these outputs. Okay, I don't want to scroll down because I want to save some time here on the video. Okay, so now as I look at part B, okay, my suggestion in part B, I think it's always easier to identify a rule once you have a table. Okay, so the first thing I would suggest doing in part B here is create your XY chart, your input-output chart. Okay, and you know you have 1, 3, and then you have 2, 4, and then you have 3, 5, and you have 4, 6. Again, compare your inputs to your outputs. What do you have to do to 1 to get 3? What do you have to do to 2 to get 4, 3 to 5, 4 to 6? I think it's pretty clear. This is pretty straightforward. Take your input value, add 2. Okay, so your output equals your input plus 2. Domain, 1, 2, 3, 4, range 3, 4, 5, 6. All right. I'm going to go ahead and leave part C for you to kind of work through on your own. All right. If you have any issues with that, let me know. If you want to make sure you did it correctly, just ask tomorrow in class, and we will go ahead and go through that in class. And then finally, we're going to look at this idea of a relation and then how to determine whether or not a relation represents a function. Okay, so a relation is just a pairing of set of inputs and outputs. Okay, so let me just see. Set of input slash output pairings. Okay. Now, a relation is a function if for every input there's exactly one output. So each input, only one output. Okay. So example 5 here. I'm going to erase this now. So if you need to pause the video, go ahead and copy that down. And so again, we're just kind of plugging away. I look at this first part down here. All right, you have your inputs and your outputs. You'll notice each input goes to only one output. 4 goes to that, 8 goes to that, 2 goes to that. Check. Yes, it's a function. Okay. The second one, 1 goes to 2, 2 goes to 3, 2 also goes to 4. You'll notice 2 has 2 different outputs. Not a function. All right. If an input has 2 different outputs, it's not a function. Now, that's how you determine based on a table. Now, you can determine whether something's a function based on the graph, and you can use the vertical line test, okay, to determine whether a graph is a function. All right. And here's what that means. All right, now I'm going to go through kind of what the vertical line test says here, and then I think once I show you, it'll be even more straightforward, okay? Okay, so when a relation is not a function, its graph contains at least 2 points with the same x-coordinate and different y-coordinates. All right, so in terms of what a graph looks like, if you look at your table down there, okay, let me scroll over to the table. So this is really what you need to know about the vertical line test. If I look at this table, if I can look at my graph and the graph, if there is no vertical line that I can draw that's going to pass through 2 points, that's a function. Okay, I look over here, 1, 2, 3, 4, 5, 6. I'm always going to go through only 1 point. That's a function. Now you look over here, I'm good, I'm good, I'm good, I'm good. But then you notice this dotted line here that they already drew. I go through 3 different points. That's no good. Okay, so that tells me this thing is not a function. So again, the idea behind today is become familiar with terminology, function, domain, range, independent variable, dependent variable, relation, and then also understand how to go from a table to a graph, from a graph to a table to a rule, and then finally just determining whether or not something represents a function based on the table and or the graph. As always, bring any questions that you have to class tomorrow, and we will go from there.